Greetings once again. Welcome to this level 4 presentation on differentiation using the product and quotient rules. In this presentation, I'm going to assume that we have already looked at differentiation of the expression ax exponent n and also differentiation of various terms or various functions using the chain rule. I'm also going to assume that you can convert surds to exponential form and vice versa, and also express negative exponents with positive exponents. Know how to convert between the two. Now consider a function f of x which is made up of the product of two other functions u and v, which are also in terms of x. That is, you can distinctly see two separate functions u and v in terms of x multiplying each other. Then to find the derivative of such a function, the derivative of such a function will be f prime of x given by the function u multiplied by the derivative of v plus the function v multiplied by the derivative of the function u. That is what we call the product rule. The quotient rule also looks at a quotient, that is a fraction, where u is the numerator and v is the denominator. That is, you will see a function in terms of x, which is on the numerator, and another function in terms of x, which is on the denominator. Then in that case, you can use the quotient rule. And the derivative of such a function will be given by this formula again, that will be given to you on the formula sheet. Right. So we are going to look at some examples on how to apply these two formulae. Question number 1, we want to differentiate with respect to x by using the product rule. The function y is equal to 3x multiplied by sine 4x. So you will see that there are two functions multiplying each other there. The first function is 3x, the other function is sine 4x. These two are multiplying each other. So because they are multiplying each other, you can apply the product rule. That is, you give them names. The first one, you call it u. Then the other one, you call it v. So our u is 3x, our v is sine 4x. But from the product rule, you know you are going to need derivatives of these two functions. So you are going to find the derivative of u with respect to x, that is du dx, which gives us 3. The derivative of 3x is 3. And also the derivative of v, if you differentiate sine 4x, you are going to use the chain rule here. dv over dx is 4 multiplied by cos x. Our formula is that. So the next step would be to substitute your u, your du over dx, your v, and your dv over dx. Do the substitution like that. Then simplify by removing the brackets. And that is your derivative using the product rule. For question 2, I want you to notice that the two functions that are multiplying each other there, one of them is having a negative exponent. Right, so In most cases, you will be required to give your final answer with a positive exponents. So you have to deal with this negative exponent, right? Okay, so our u will be the first function 5e exponent 2x or negative 2x, and the v is cos of 7x. Then we need to find the derivative of u and v. We can also use this notation where we use u prime to represent the derivative of u with respect to x. So again, this is actually applying the chain rule in a way. We are going to get the derivative of e to the power minus 2x. It's e to the power minus 2x, but you multiply that by the derivative of negative 2x, which is negative 2. So you are going to multiply 5 by negative 2 to give you negative 10 for this part. Then also for the derivative of cos 7x, derivative of course is minus sign, so you have minus sign 7x, then you multiply by the derivative of 7x, which will give you 7. So your v prime is negative 7 sine 7x. So you now apply your product rule. The formula says u times v prime plus v times u prime, which is equivalent to the other formula that we wrote in terms of dv dx and du over dx. Then the next step is simply substituting those terms that we already found there. You will see that this one is here. Then v prime, then we have v, and we have a u prime, which is this one, right? And it's plus in between them there. Then the next step is simply simplifying. But our solution at this stage is having negative exponents. So to make a negative exponent positive, you simply take it down to the denominator. So you take the minus e to the minus 2x, take it down to the denominator for both terms. Then you have that as your final answer with positive exponents. Question 3, we have the function y is equal to 3x times square root of 5x cubed minus 2. So our two separate functions are 3x and square root of 5x cubed minus 2. You can write 5x cubed minus 2 square root of that as a exponent half, so that you can differentiate the way you differentiate ax exponent n. So we can call the first term u. 3x is equal to u, and we will let v to be 5x cubed minus 2 exponent half. Then because our product rule requires us to find the derivatives of these two functions, we find the derivative du over dx is 3. Derivative of 3x is 3. For the second part, or for the v, you are going to apply the chain rule to differentiate. That is, you are going to take the half, it multiplies here, then you subtract 1 from there. Then you multiply by the derivative of that function, which we have there. And the derivative of that function, you will see the derivative of 5x cubed. Again, you take the 3, it multiplies the 5, then you subtract 1 from 3. Then the derivative of the constant will give us a 0. So this term here will be 3 times 5, 15x. Then 3 minus 1 is the 2. Right. So that is applying the chain rule. Then the next step, you write down your formula. You write down your formula. Next step, substitute into that formula. You already have all these terms. The simplification of this, please, I'm not going to spend too much time on this. What you can do, you can pause the video and try on your own, because the focus of this lesson is really not on simplifying algebraic terms, but on differentiation. So what we have done here, applying the product rule, is what is my objective for the day's lesson. So the next step, we are simplifying, multiplying 3x by 15x squared, and also taking the 3 to this side. We have that expression there. Then, because there is this negative exponent, we would want to write it as a positive exponent, so we take it down to the denominator, joins the 2 there. So we have 45x cubed as a numerator, then this 2 here is here, then this negative exponent half will make it positive exponent half, and exponent half is square root, so that's why we have this square root here. Then this part here, again, the square root, we write the exponent half, we write it as a square root here, and that is the final answer. Now we go to the quotient rule. Remember, we said that we use the quotient rule when we can identify fractions, right? One function will be a numerator and another one a denominator. So in this case, you will see that we are having the function 4x is our numerator, and the function square root of x squared minus 4 is our denominator. So we can use the quotient rule in this case. And for the quotient rule, we have to make u equals to 4x, and that x squared minus 4 square root will be our v, right? Then because of the square root, we know we have to express it as an exponent. So when we differentiate du over dx, it gives us 4. Then the derivative of that, again, we use the chain rule to do that. I'm not going to go into the detail on how to do that. Then we write down the formula that I said it will be on our formula sheet. Then the next step is simply substitution, where we have v, we put square root of x squared minus 4, where we have du over dx, we put 4. Where we have u, we put 4x, and where we have dv over dx, we put this. Right. Then v squared means we are just going to take this one and we square it. That is what we are going to put here. And see that if you square it, the square root will go. So when we substitute, we should come up with this. Right. I think you can pause and just check how we do this particular substitution. Right. Then the next step is about simplifying. But I want you to notice that our differentiation ends here. We have used the quotient rule to differentiate. Up to here, you have done your differentiation. What you are now doing is addressing that part that says you need to leave your answers with the positive exponents and also in said form where appropriate. So that is what we are going to do like that. Then maybe if you want to remove the square root or the fraction in the numerator so that your function doesn't look that messy, you can multiply both numerator and denominator by square root of x squared minus 4. So you multiply each and every term there by x squared minus 4. This one will also be multiplied by x squared minus 4, and this one will also be multiplied by x squared minus 4. This term here, this part here, when it's multiplied by x squared minus 4, you will see that the square root will go because it's square root times square root. So the square root will go. Then for this one, you will see that this and this, they will cancel each other out. Then this one, the denominator, because we have x squared minus 4 and the square root of x squared minus 4, it's exponent 1 and exponent half. So you have to add the exponents there so that you will come up with this result. Then when you remove your brackets on the numerator, you can remove the brackets and simplify. You remain with minus 16 on the numerator. Then on the denominator, we want to leave our answers as surds. So the denominator in the exponent is a root. So this is a square root of cubed. So that will be our final answer there. But remember, I said our differentiation is up to here. All this is actually level 2 work, which you did in level 2. And I don't want to discourage you. But if you don't know this, please go to your level 2 and try to study. Don't spend too much time on it though. I have done a lot of talking. I will quickly go through question number 5. Right. First step, identify the fraction and find your u and v. Your u is the numerator 3x plus 1, your v is 3 ln x. You need to find the derivative of these functions with respect to x. Derivative of u is 3. Derivative of 3 ln x is 3 times 1 over x, which is 3 over x. Write down your formula, the quotient rule, then substitute into the formula. Each of those terms, you substitute them into the formula. This is the quotient rule. You are done with your differentiation. Any other step that you do from here is just to simplify. So I would simplify up to there. Please notice that the way I simplify there, I do not have negative exponents. I do not have surds. So I'm satisfying the conditions that are required for this question. You may simplify in other ways, like taking like factoring out a 3 and stuff like that. But you can also leave it like this. That will be fine. Question 6 will be my last problem for the day. Right, I want you to see that this is a problem that can be solved using the quotient rule. Right, your numerator is your u, your denominator is your v. Then you differentiate them, but c is in respect with t. So we have to write du dt and dv over dt. Those are your derivatives of u and v respectively. Then you write down your formula. Notice I am putting again dt because my function does not have x, it has t. So it's dy over dt is that. Then substituting straight into the formula, we have that result. That is applying the quotient rule. What follows now is just to simplify. Right, we can remove the exponent outside there by multiplying by 2t. So it will be this multiplying by the 2t there. So that we have a 4t. Right. Then we can also separate the fractions. Write them as two separate fractions so that we can even simplify further. When you divide e exponent 2t by e exponent 4t, you can use laws of exponents. But however way you do it, you will see that your final answer will be that. Right. Now, I also want you to see that this question can also be solved using the product rule. That is, if we write it as 6t, then making this to be a negative exponent, that is taking it up to the numerator, it will be e exponent minus 2t. So this becomes our u, this becomes our v. Then we use the product rule. And applying the product rule, we have that. I'm not going to show all the steps. You can do them separately. Write u, du, dt, and v, dv, dt, like that. Then finding the derivative, simplifying the derivative of e exponent minus 2 is that the derivative of 6t is 6. Then simplifying further, removing that bracket, then writing the negative exponents as positive exponents, you see that our solution will be the same as that. So that is it for today's lesson. What is left is for you to go to this textbook, your textbook, and attempt the following questions. You see 6.5 and 6.6 learning activities, number 9 and number 4 respectively. You can do those and try and check your solutions which are at the back of your textbook. Then the other questions on the summative assessment of the module, I would expect you to do them and send your attempted solutions to me. So enjoy solving your mathematical problems. Stay safe. Take care of yourself. See you next time. Bye-bye.